Well, good afternoon, everyone, and welcome to today's Fireside Chat with Derek Limsu, CEO and co-founder of Peak Power, and Farid Madhani, the CFO of Peak Power. As most of you know, I'm James West, and I run Sustainable Technologies and Clean Energy team for Evercore ISI. Peak Power is a clean tech company focused on software solutions that forecast grid events and aggregate distributed energy resources. Peak Power is helping industrial and manufacturing facilities, large commercial buildings, and independent power producers get greater returns from their investments and pursue net zero goals. Derek, the CEO and co-founder, is a high energy entrepreneur with over 20 years of business experience in the clean technology and energy sectors in senior leadership roles encompassing business development, capital raising strategies, mergers and acquisitions, technology development, and overall executive management. And prior to Peak Power, Derek held several senior executive positions with global clean tech companies as a member of the Young President Association Toronto chapter. Farid is a CFO, and he is a climate finance professional with extensive experience in scaling functions for growth companies. Before joining Peak Power, Farid led and grew the project finance function at Northland Power, executed M&A and financing transactions for utility scale renewable projects in the Americas and Europe. So gentlemen, thanks for joining me today.
Thanks for having us.
Absolutely. And so for our listeners, I obviously have a ton of questions to ask these guys, but if you have questions along the way, please do not hesitate to put them in the Q&A box, and I'll make sure to get those questions over to Derek and Farid. So maybe to start, can you share with us the origin story of Peak Power and the company's mission, goals, and priorities?
Yeah, so maybe going back to where I started my career. I started my career working for General Electric, managing renewable sales, where what I was taught was essentially bigger was always better, right? And always bigger wind farms, bigger gas turbines, and that was the way to solve the grid. And when I was there, I saw a trend in the market towards distributed generation, where back in the day it was called many different things: microgrid, smart grid, smart city. Now it's called energy transition. But the overall premise was that there was going to be a need for more flexible, resilient, cleaner devices that would be located closer to where the load pockets needed. And that'd be the way to help balance the future of the grid, right? Peak Power is essentially a software company at the heart. That's where we started, right? And the reason why we started there was because we believe that to be the kernel of the distributed energy resource market, that somebody needed to understand a lot of data and develop a lot of analytics to tell devices that were smaller how to act like a bigger device, right? Since our companies have evolved, we've gone up the value chain, and now we're more involved in origination, development, and financing combined with our proprietary software. So today, Peak sits at the intersection between technology and infrastructure, where we can offer full turnkey end-to-end solutions that we call energy storage as a service, or software-only solutions that we call SaaS. Some of us refer to us as an infratech company, right? So being an infratech company, now we have the ability to offer our customers abilities to lower their energy bills and achieve their climate goals. Every budding young company needs to have a very, very ambitious mission and a big audacious goal. Our mission is essentially to drive the clean energy transition by optimizing distributed energy resources with our software, right? And our big audacious goal is that if we can do many of these virtual power plants, we can essentially make many more dirty power plants obsolete by offering cleaner, more flexible, and resilient solutions.
Gotcha. And what do you think the total addressable market is here for the company, and what do you see as your main strategy to capture market share?
Yeah, so I think Guidehouse estimates the market to be about $120 billion by 2030. It's growing at a CAGR, greater than 30%. I think the TAM Samsung is all growing, and that's really, really interesting. I find with my career, having lived through wind and solar, I've never been in an opportunity where the value of what a company like Peak Power is doing is increasing, because the cost of peak demand, the cost of energy is increasing, and the cost to deliver it, or the value of what we're doing, is increasing, and the cost to deliver it is decreasing, meaning the capex of the hardware is decreasing, and hopefully the financing rates are as the debt rates start to drop, right? So I think that I'm super excited how big the market is, and essentially our strategy in terms of how we plan to scale and take our portion of the market is kind of through three main channels, which goes back to our infrastructure and our technology side. The Achilles heel of trying to go after smaller sites is it's expensive if you don't establish strong channels to market. So really, it's just making sure that we go through our direct, our partnership, our acquisition strategies. Direct is tough, right? You probably make the most money out of it, but you start from the beginning. You start from a brand new relationship that you don't know them. You've got to establish trust and then get them to sign an agreement, then deliver on their promises, and then land and expand. Partnership is great because you can borrow someone else's credibility and start kind of halfway through the relationship. And then acquisitions, you just buy a project at a later stage. So a combination of those two we're going to be focused on in order to find that right balance for us to grab our portion of the market share. Because we're doing the infrastructure side, making sure that we can streamline the project finance to make sure that we can overcome the diseconomies of scale of financing smaller projects, and making sure that Farid and the team can efficiently finance smaller CapEx projects in a cost-effective and effective way, right? And the third one goes back to our tech, which is really around making sure that we can differentiate ourselves in terms of the experience the customer has on how we set the promise with our software and forecast what we can do, but really make sure that we can deliver on the promises that we had over the next 10 to 15 years of the savings that we promise on their energy bills, of the revenue we're generating from the grid, and on the greenhouse gas reduction that we promise to them and their shareholders that really value ESG.
And Derek or Farid, why do you think that the centralized grid model is obsolete and no longer works, and we have to go distributed? I mean, is it purely the lack of transition, the lack of the high cost with accelerating the grid? I mean, what are the main issues standing in the way?
I mean, having been in the energy sector for 23 years, I think this is not a new thing. I think people knew this was the case. It's just energy is not known to be a very innovative space or fast-paced innovative space. The traditional grid has a lot of issues, but if you look at the macro impact that's exposing a lot of the fragility of the grid, it's really climate, right? I think that you're seeing unprecedented amounts of climate-related events, Hurricane Ida, Winter Storm Uri, that have all had widespread outages based on aging infrastructure we'll talk more about as well. But essentially the weather patterns, the hottest days are getting hotter, the coldest days are getting colder. The swings between the hot and cold have never been seen before, where you can go to, I'm going to talk Canadian here, but you can go to, minus 10 Celsius, which would be, I guess, 30 Fahrenheit, and then go all the way to like 65 or 70 the next day, right? And I don't think the grid and the infrastructure was ever built, and not only electrical infrastructure, just general infrastructure was never built to see those swings, right? I think so. You've got climate, which you don't control. And the thing you do control is this forecasted demand is unprecedented. And the electrification of the transport, the building, the industrial sectors is having a huge impact that the forecast of growth has never been seen before as well, right? So the fact that the EV adoption is starting to increase more and more and more, we're going to phase out combustion vehicles. That's going to have a huge impact. And not only will it have a huge impact on the charging piece, but the charging patterns. It's not easy to assume that everyone's going to charge at home. People will be charging at work. And how do you forecast that load growth where that's going to happen? Building electrification, as everyone goes from traditional fossil fuels to go to more electrification for heat pumps and so on and so forth, will have huge impacts in terms of that piece. And then industrials that are going to electrify their processes will have huge impacts on the demand. And all of that will stress a grid that's really, really old, right? A really, really old grid that has been talked about for a long time. 70% of the US's grid is over 25 years old, and most of it surpassing 50 years, right? So you've got climate, you've got crazy load growth, you've got an aging infrastructure, you've got a grid that wasn't designed for flexibility, which is what was required when you've got unprecedented load growth and climate change. And the last piece, which people have talked about it being prosumer, whatever you want to call it, your consumers that are buying the energy are just so much smarter. And they have multiple options now that they can install their own embedded generation, DERs behind the space. So things like when energy storage got commercialized, which really has been the holy grail of being able to store electrons where they're cheap and in abundance and dispatch them when they're valuable. And it's just forcing a strong discussion of what the grid needs to look like and why the grid of one where you just install large centralized fossil power plants that needed a day's notification or 2 days to fire up just doesn't work. And I do believe that the future will have a portfolio. It's not going to be all eggs in one basket. There's going to have to be a portfolio approach that kind of blends the old and the new, and that may vary by region what is acceptable.
Right. Well, I know you guys raised, I think, 35 million in a Series A investment round last year. Could you share more about that and kind of its relevance and how it's helping you accelerate your growth?
Yeah, it's a good question, but perhaps I can start by providing some context. Before that
Sure.
raise, Peak Power was very fortunate to be trusted and supported by leading institutional investors in Canada, like Osmington, which is the family office of Thompson family, the investment arms of Canadian Crown corporations, like Business Development Canada, Export Development Canada, and early stage funds like Mars Investment Accelerator Fund and Toronto Atmospheric Fund. So with all of that capital, we were able to build a very strong technology, and we'll talk more about it. We were able to demonstrate a track record of developing, building assets, uh, um, operating them efficiently in Canada, and we were also able to demonstrate projects in the US. And as we did all of that, we realized that the majority of our growth is going to be in the US. And hence, as we were raising capital, our plan was to raise capital from a like-minded investor that not only shared our values, but can help us with both the infra and the tech aspect of our business. A greenbacker, through a series of funds, has deep expertise, not just in renewable energy development, but also in helping scale early stage organizations. And hence, we are very lucky to have them as the lead investor of the last round. And we're very grateful for their support, and we make a really good team together.
Right. And so maybe just get a little bit into the business here. Could you talk about the operation and software solutions and help us understand how exactly the software works? And I think you put a number out there fairly recently that you've helped your customers realize over 5 million in financial benefits.
Yeah, no, I'm happy to. Maybe I'll describe our software offering in under 5 pillars, right? So our overall platform, our overall tech platform is built on a strong foundation. What's the foundation? The foundation is a strong data pipeline, a strong software architecture that allows us to just grab lots and lots of data, both structured and unstructured, and store it reliably in a cost-effective manner, right? That allows us then to take that data and then actually focus on our forecasting component of our piece, which is the kernel. It's the ability for us to be able to forecast the most expensive and dirtiest hours of peak demand. Our forecasts rely on these millions of data points that we store from external and proprietary sources in our foundation and in our data pipeline. Once those forecasts, they go into our optimization engine. So our optimization takes these forecasts, grid signals, energy market prices. They look at the limitations of the asset, the actual battery, the solar, the building itself, the load that's there, to basically find a balanced optimization approach, which then essentially feeds out an autopilot, right? A set of instructions on how these assets need to operate to maximize revenue and minimize the operating costs of those assets, right? So when that optimization API then goes over to the actual devices, then we have to make sure that our control and monitoring portion of the software is working, and the ability for us to be able to implement these commands, making sure that we understand, again, what's happening with the devices, what's happening with the load, what's happening with the grid, and all the while making sure that we're continuously monitoring what's happening with the assets and making sure that if there's any anomalies that are occurring on the grid, any anomalies in prices, any anomalies in the asset life, that we're able to react to those. And the last portion of our software is around reporting. So if you've done a really good job of making sure that you have the data and all that's being stored and you know what data to get, you're forecasting things with a high level of accuracy, it's feeding into your optimization algorithms, which is proving to be within a certain margin of what you forecasted to go do, you're controlling and monitoring your assets, then the next piece is just your automated reporting, making sure that you understand the rules of engagement, how it all settles, and making sure both your investors, your customers all see with transparency how you've done, right? And that's kind of how I'd explain our software in the most simplistic fashion is, foundation, forecasting, optimization, control and monitoring, and reporting.
Right. And I know that when we talked in the past, you've made that you think the future of electricity in large urban centers are virtual power plants. I'm curious as to why you say that, when I think a lot of people think it's still centralized in big cities. And then maybe to add on top of that, since it's obviously the hottest topic in the world today, is what's the role of AI in all of this?
Yeah, we will start by saying that in order to solve the climate crisis, we need all hands on deck. So virtual power plant are an important contributor to solving the climate crisis, and they are well suited to support and complement the existing grid in the urban centers. Now, urban centers is where the load is. That's where the most variability within the demand happens. Let's take electrification as an example. When are electric vehicles getting charged? When they're not getting charged. We're moving into heat pumps. We are electrifying various industrial processes. So we have not only an increasing demand, but increasingly variable demand. So as a society, we have a decision to make. We have a decision to make: how do we put in our time, our financial resources into solving the electrical problem and solving the climate crisis. VPPs, or virtual power plants, use what is otherwise latent space within our communities. That could be a carport in a multifamily residential place. It could be a roof on a warehouse, or it could even be an extra car park next to an industrial facilities. So you're using latent space to create electrical generation, storage, solar, and the like, which can respond to the flexible need that the increased electrification and increased changes from climate are doing. And now if you think about like what you're trying to do, you're trying to have all these small distributed assets talk to each other, get signal from the external environment, get signals from the grid, and get signal from the demand from the customer, and take all of that data. And it could be as detailed data as, based on the sun and new construction, how is the shade impacting a building's consumption? When is the holiday? And the only way you can do all of that is through AI, because you need a system which can process millions and millions of data points and create an accurate signal so that these assets can dispatch and they can act as virtual power plant. And I'll say again, they are a complement to the existing system, and an important complement.
Right, right. Well, maybe you mentioned storage. So I'd love to talk a bit about your Peak Synergy software and how it operates in the storage, in the optimization of storage, if you wouldn't mind.
Yeah, so I think I kind of explained it in terms of how our software works. So maybe I'll talk about maybe a little bit earlier on before all that happens, right? So in order for us to enter into a market, what we first do is we research a lot in terms of with our product and market team on the policy, the rules, the regulations we need to adhere by, right? We build out our value proposition on how we can provide value to our customers and how Peak can actually make money, right? So we then determine what data we need, right? So then that's going to the foundation. We figure out, hey, what data we need to secure to make sure we can feed all those 5 pillars: the foundation, the forecasting, the optimization, the control monitoring, and the reporting. And then we quickly move to a proof of concept, right? To be able to test on virtual assets that we can actually make money with batteries in these markets. And they're within the realm of us being profitable from that dynamic, right? Our software is active in 4 ISO regions already. So now we're at the stage where the business is today is we're kind of replicating. Many of the ISO regions have copied each other, right? They may not have the same weighting in terms of what a coincident peak or a capacity payment is, or arbitrage, but they all resemble each other, right? So once we've done 3 or 4 regions, we're able to enter a region pretty quickly. But it all comes down to the macroeconomics of whether that project makes sense, which really is, what is the revenue stack that's available versus the cost to deliver storage versus our profit margins that we want to make, right? So that's essentially what we do in every market. And I'd say today, as you see more and more regulations occur where they're, either providing more economic incentive, like solar, like wind, you'll start to see every single state in the US start to open up. And that's just starting now. And I think the IRA, is that spark that's going to get, the first initial states to really balloon.
Yeah, we totally agree with you there. Maybe let's move to the development part of the business, and the distributed energy resources you guys are putting in place, the disruption they're causing, and just overall Peak Power's approach to development.
Yeah, absolutely. So I'll talk about development in a bit, but let's first align on the definition of distributed energy resources.
Sure.
So in our parlance, we call a distributed energy resource, which is typically a small asset, maybe 1 megawatt, 5 megawatt. It's an asset which is close to the load center, so it's at a customer's property, and there is something already out there. So either a multi-residential home, there is a warehouse, an industry, there's something already out there. This is what we call DER. And within this space, we operate in the segment that serves commercial and industrial companies. We don't focus on the residential part. So if you think about the development business, any renewable energy development or even non-renewable development in the power side, you basically need three things to develop an asset. You need land rights, you need permitting, and you need interconnection. And fourth one, if you're lucky, you can get a power purchase agreement. If you think about distributed energy resources, you can get a lot of it just by the nature of it, because your customer is also the landlord. Your customer is also the off-taker. Your customer has been in existence, so they're operating their business. So they have received geotechnical or environmental permitting. Your customer already has certain electricity demand. So the interconnection or connection to the grid, connecting the wires, is a de minimis expense for the utility. So from a development side, we see DERs as being more, I would say, more that they are fast and responsive from a development perspective, shorter development cycle. And then from an operational perspective, we've talked about it a few times now, they are more resilient and they are more flexible. So they can address changes in demand and supply very quickly. And if you think about, distributed energy resources, the development cycles are short, and as a result, the development team that we have built is a strong development team who has tons of experience of doing similar work in other renewable energy assets. So this is what we call the infra side of our business, and hence this infra side complements the technology side by bringing in more business closer.
Right. Okay, that makes a lot of sense. And maybe could you also provide some details on the company's commercial and innovation projects, and perhaps if you have a few examples and kind of how Peak Power played a role?
Yeah, so I think there's probably like 3 projects I can mention. Right in our backyard here in Ontario in the IESO, we've been doing for a while a multi-asset virtual power plant. For several years, we've been operating a swarm of buildings, electric vehicles, and batteries to respond to grid signals and our forecasting signals. And they've been spread across a range from large commercial office buildings and industrial facilities, right? Actually, in this VPP, we actually were operating 20 Nissan Leafs in collaboration with Nissan doing vehicle to grid. So you can imagine, having operating different asset classes for this piece, understanding when they're available, understanding how they respond, understanding the notification when you're dealing with drivers. A lot of learnings have come about for us to understand how we can then deploy this in other regions across North America. In the CAISO market in California, we've got a partnership with Mitsubishi's Diamond Generation Corporation, where we operated the first of its kind through the meter battery, operating under FERC Order 841, right? This through the meter application at the one of Caterpillar's manufacturing facilities provides behind the meter service like demand side management, but also front of the meter grid side service report like demand response. So you're starting to see more of this in California, and you'll start to see this more in other regions. So that was a pioneering piece that we hope to replicate more and more in other regions. And then in New York, again, I don't think it's as novel today as it was at the time. In the county of Westchester, New York, we actually were one of the first virtual power plants using 4 Tesla batteries at GHP's facilities. So in partnership with Kruger, we've been operating these assets for a number of years. The software is essentially aggregating these things and today operating within the VEDR program. But at the time it was through the Con Ed Demand Management Program that we were able to build the project on. But as the rules and regulations have changed in New York, these assets have now merged into the VEDR stack that exists there today.
Interesting. And then maybe if we could talk about some of your strategic partnerships and collaborations, how they contribute to the growth and development, and maybe if you want to, the recent partnership with Switch Energy.
Yeah, I think that, for us, if you go back to your original question about how we're going to go after and convert the TAM, our biggest thing is around channels to market and really focusing on partnerships, right? And working with people who serve C&I customers that recognize the need and the value of what energy storage or solar plus storage can bring to their facilities, right? So we tend to partner with people that have access to host sites, people where their customers are asking for that. And I'd say in the last year, with the ESG and everything going on in the IRA, the amount of requests we're getting from our partners that their customers are asking for it. So we tend to want to partner with those, right? So an example of those would be like a Generac, right? So we did a webinar with Generac. Generac's a big time player in the backup generator space, but they're also battery integrated. They're also very innovative on the grid side as well. So with them, the idea is that they are the hardware solution to be able to provide the hardware, and we can be the brains to be able to have the on-site optimization. But also, many clients don't have the balance sheet to be able to purchase these assets, nor do they want to because it's not their core business. So we offer our full turnkey approach, where we can also offer the development and the financing off of that. So in that situation, we target Generac's customers. We also look to use Generac's battery offerings on our portfolio as well. And the idea is that we enter into these shared savings agreements with Generac customers, where we'll give them a certain percentage of the revenue that we can generate from these assets, and the rest we keep to be able to finance the assets and for Peak to make their return, all the while Generac gets to be able to sell their equipment and get the service revenue from that piece, right? Along that value chain, there's also people that are EPCs, right? So people that are basically, turning the wrenches, installing the foundations and so on and so forth, that are solar installers, that could be solar developers that we team up with as well, right? To basically bring us sites that perhaps solar can't be oversized anymore due to like NEM 3.0 in California. And all of a sudden the necessity for a battery is important. The common theme around all of our partners, it's not straightforward to model storage. So they all require a translation. And that's the first service that Peak does. We provide a translation to be able to explain the impact of DERs and batteries for their customer. And then we have the ability to take that and then be able to explain that to a financier where they can price that risk, and we can then, finance it in an affordable fashion, right? So I'd say on the channel to market side, it's really been around Generac, EPCs, solar developers. On the project finance side, we'd announced with Madison Energy Investments. So Madison Energy Investments, player in New York. They are one of our partners with regard to financing. And again, they give us a path to reliable, cost-effective financing, which is part of our full turnkey end-to-end solution. So as you look at, those are more the day-to-day transactional pieces to grow our day-to-day business. And on the flip side, we also have innovative partnerships, right? Where Switch comes into play and others, where essentially we're always looking to test the limits of our roadmap to kind of figure out where we want to go, where the future is going to go. We look to leverage government grants and subsidies to be able to help us test and experiment, right? Because in an industry like the energy, where innovation is the only key to solve our future grid problems, we have to have the ability to play and innovate. And that's where the Switch partnership came about. Switch is a Canadian EV company where we've integrated our Peak Power software with Switch's software to allow the EV chargers to respond to grid peaks. So our view of the future is that, every single building is going to have some sort of an EV charging structure, whether it's V2G or V1G. It's going to have a battery instead of a diesel engine as backup that can be used for other reasons. And if possible, there's going to be some generation of solar of some sort that's going to be combined on that site. And those three things are going to all have to talk to each other. And I think that today, when I say that, it's probably more reality than it was 5 years ago. But if you look at what has happened in the building sector, where so many disparate systems have been installed that don't talk to each other, we're trying to avoid that. Where in the build sector, you've had someone install HVAC, someone install lighting, someone install the BMS, and they don't talk to each other. I think on the energy side, it's too complex because it's not about energy efficiency where it's kilowatt hours. It's about the grid and it's about settlements. I don't think that's going to work that way. So as a result, we think there's a great opportunity for someone to aggregate all those sites. And that's where Peak Software will come into play.
Right, right. Well, could you maybe talk also about the competitive landscape for the industry, and how do you feel like you're differentiating yourself from maybe established players or even some of the emerging startups?
I would say the biggest differentiator for us is we do development better than any technology company, and our technology is better than that of any development company. We've been able to combine these two disparate things, put them together as an infratech solution. So for a customer who has an OpEx problem, we're able to provide them with an OpEx solution where they don't have to put in any costs. For our asset level financiers who have not been able to participate in the CNI battery storage projects or solar plus storage projects, we provide them with an opportunity to invest in those. And then for the grid, we are able to optimize all of those things. So what I would say is on the software side, there are several players who can provide software. We have one of the leading software performance, but there are other software providers like STEM and Ascend. And on the development side, there are a few players like Enel Green Energy, etc., who provide different solutions. But again, the way we differentiate ourselves is by combining both of them together, because the customers have very good reliance that we would actually be able to deliver on the savings that we have said, and the projects will actually get constructed because we have financing partners. And likewise, the financing partners can underwrite the investments because they have confidence in our ability to deliver.
Right. Well, last question for me, guys, before I let you get back to your day jobs. What are some of the key milestones we should be watching for, and then the goals that you have over the next 12 to 24 months?
I think it's pretty simple, right? Our focus is around scaling growth in the US market, right? So post IRA, the US represents an incredible market opportunity for our company. It's the biggest one we have, right? And more and more policies are coming into place to remove barriers with DRs, like we're seeing in California a couple of weeks ago, right? Costs have dropped and stabilized on the CapEx side for switchgear, for batteries, which won't last forever, but today they look pretty good. And finance rates, I hope, only have a path to go down, right? And I think a combination of those are going to, have significant growth in the foreseeable future. And really just focusing on what we talked about, broadening out our direct partnership and acquisition strategy to increase our pipeline, our conversion of the TAM. So, I think I'm super excited for the next 12 to 24 months. And I think, all the while making sure that we continue to build a world-class corporate culture. We have fun, keep our heads down, and we execute on our promises. And I think we're lucky that we have a group of 72 employees in the company that are all bought into our mission and our vision, and wake up every day to kind of push the needle a little further. It's a marathon. It's not a sprint, right? And energy goes slow. But I would say that when you look at all the things that have happened over the last 12 to 24 months, and all the good news that have happened to make this market where it is today, I think the next 12, 24 months are going to be even better. So I'm excited to be there with Farid and the team.
Absolutely. Well, we're excited about it as well. And we're excited about the model you've put together, and we look forward to watching your progress. So look, Derek, Farid, thanks so much for joining me today. Enjoy the rest of your afternoon, and hopefully we'll talk again soon.
Thank you.